physics, there are two types of physical quantities. They are scalars and vectors. Scalars, there are no directions, only magnitudes. Examples: mass, time, distance. Mass is measured in kilogram. Suppose you buy 4 kilogram of sugar and your friend is giving you 3 kilogram of sugar. So total amount of sugar is 7 kilogram. So you can simply add. Similarly, morning you study 4 hours, evening you study 3 hours. So totally 7 hours. Distance is measured in meter. First you walk 4 meter and then you walk 3 meter. So distance traveled is 7 meter. But displacement is different from distance. Let us try to understand what's the difference. Suppose you walk 4 meter, then you walk 3 meter. So you know distance is 7 meter. Displacement is also 7 meter. Then what's the difference? Suppose you are changing the direction after walking 4 meter, you change the direction of your walking 4 meter. Then again, instead of going in the straight line, you are walking in another direction 3 meter. So now distance is 7 meter, but displacement is not 7 meter. Displacement is the shortest distance from the starting point to the final point. So now this is the displacement. Displacement is the change in position. So here, using Pythagoras theorem, you can get the hypotenuse. This is 90 degree. You're walking at right angles. So now displacement is 5 meter. Distance is 7 meter. So magnitude of the displacement is 5 meter. Then there is a direction. So displacement is a vector quantity. There is a magnitude and direction. Suppose now after walking 4 meter, instead of going up, suppose you are going in another direction, same 3 meter, but still magnitude of the displacement is same 5 meter, but direction is different. So here displacement is in this direction, here displacement is in this direction. Still in this case distance is 7. In this case also distance is 7. So distance is a scalar quantity. Displacement is a vector quantity. Vector quantities can be represented by a directed line segment. So the length of the line segment will give you the magnitude of the vector. Then arrow mark will give you the direction. So here there is a starting point. So then proper scale is to be selected. So if you represent 1 meter by 1 centimeter, so 1, 2, 3. So 4 meter can be represented. Suppose it is 8 meters, so you have to use a arrow mark of double the length. This is 8 meter towards the east. This displacement is towards the east. So vector quantities can be represented by directed line segment. Magnitude is given by the length of the line segment, and direction is given by the arrow. This is the same magnitude, but it is in the upward direction. Different types of vectors. Equal vectors. Two vectors, A vector and B vector, are said to be equal if they have same direction and same magnitude. And it should be of same quantity, same physical quantity. For example, force, this is also force, or this is displacement, this is also displacement. Now, collinear vectors. Collinear vectors, there are two types, parallel and anti-parallel. Two vectors are said to be parallel if they are in the same direction. So theta is 0 in this case. Two vectors are said to be anti-parallel if angle between them is 180 degree. So both of them are known as collinear vectors, parallel and anti-parallel. Definition for collinear vectors. Two vectors are said to be collinear if they are acting along the same line. So in this case, same direction, here opposite direction. In this case also, they are along the same line. So this is A vector and B vector. You can represent like this. So it is along the same line. So two vectors are said to be collinear if the vectors are acting along the same line. Then unit vector. If a vector is divided by its magnitude, this unit vector. So magnitude of the unit vector is 1. So you divide the vector by its magnitude. So it can be represented A cap or A hat. It is represented like this, and it is read as A cap. Then orthogonal unit vectors. X-axis, Y-axis, Z-axis. Unit vector along the X-axis is I cap. Unit vector along the Y-axis is J cap. Unit vector along the Z-axis is K cap. So they are called orthogonal unit vectors. So the angle between them is 90 degree. They are mutually perpendicular. So they are known as orthogonal unit vectors. Thank you for watching.